As is fairly common in this retro computer hobby, things are rarely ever as simple as they first appear. And this little A600, this most definitely ticks that box. This belongs to Mitch, or Twilight 1964, as he goes by online. I had been trying to help him over on the CRG Discord, trying to diagnose what was wrong with it, because he wanted to have a go at trying to fix it himself. But ultimately it just became too complicated, so we have it in front of us here, and this one, it works now, but it was most definitely quite the test. Replacement pads, loads of patch wires, cracked solder joints, problems on the composite video, and we didn't have a soft reset working. So a plethora of problems that needed sorted in this little machine. But it also came with a letter, so we start by taking a look at that. As discussed, here's my 600. It's been recapped and I suspect it's a problem with the reset circuit. As you will see, it's a bit of a mess. They are partly due to my ham-fisted attempt to fix it myself. There's two lifted pads on the caps next to the 555. The SMD cap fell off when I was trying to solder the other cap back on. I thought it best I stop and leave it in your capable hands before I do even more damage. Well, obviously Mitch hasn't seen the Commodore PC video, but we'll do our best. And I suppose we should start by opening it up. Just 4 screws get you inside a 600. That middle one must be stripped. And don't forget the incredibly short LED wire. What colour ribbon do we have on the keyboard? It's a green keyboard, is it? No, it's actually a replacement membrane. Interesting. That's one of the new hard membranes, I think. Yeah, I'm pretty sure that's exactly what that is in there. So I've never seen this type of arrangement before. I think that's one of the new hard membranes with that connector on the back of it there. Much the same as the one on the motherboard. Then you have this ribbon going from A to B. I'm just going to do a full teardown on this. We'll get the motherboard out of the case. And yeah, I know he said it's not working, but the first thing we'll do is test it. Or maybe not actually, because now that we're in, now that I've had a chance to take a look at it, this area here around the 555, it definitely needs a little bit of love, and I'd rather do that before we try to power it up. Now, as I said, it has been recapped, or mostly recapped, because just had a quick chat with Mitch, and the guy who recapped it for him didn't change these two, so we'll need to do that, although they wouldn't stop it powering up. And it seems it's also had the composite encoder upgraded, along with the RF CAN delete. But I'm not too sure why they left those 3 100 microfarad caps on, because I was pretty sure you could remove those if you were removing the RF modulator. I'll just double check that, and if that's right, I think I will remove them, just to give a little bit more space here, should Mitch ever want to use this area for something else in the future. With the encoder upgrade as well, well, that was done because the cans here, they were faulty, so they've been removed. Not really sure why that one was left in place. It can be removed, because on the bottom side, well, you can see all these components have been removed as well. That is correct, you need to do that if you are doing that composite encoder upgrade. But unfortunately, it seems as if the board got delaminated there just a little bit. Not to the end of the world, of course. I mean, it'll still work fine. But the solder here has been left a little bit rough, which is more evident on the top side here. So we'll just go around and tidy all that up as well. As for this bit, and for the work that was done around the 555, which controls the reset, the first thing that jumps out there really is, what's that? Little bit of stray solder. Quite a big bit of stray solder actually. So depending on where that was lying before, that no doubt could short something out and stop this machine from booting. But yeah, we sort of became convinced that there may be a problem in the reset circuit on this. So Mitch tested a few things around here. He removed this capacitor, and obviously the cap that used to be there used to be a 100 nanofarad ceramic in there, but we've lost a pad at that position, and I think he lost a pad on the positive side. of this electrolytic as well. Hence the wire running down there to those two pins on the 555. There should be a trace there that connects those. So I think what we should do is just undo all of this. We'll remove that cap, remove that bit of wire there. I'm not sure if he had the 555 off or not. It looks as if he might have had it off. In fact, the board does feel slightly delaminated there as well. So I think what we'll do is maybe remove that as well. If the board has been delaminated, I will need to be all of the careful here. As you know, I would just traditionally use hot air to remove ICs like that. But if the board is already damaged, using hot air on it again will just have it fall apart. But let's see how we get on. I'll put a bit of flux down. And then we'll just go in with the hot air. I've got this set to 385. Let's see how it goes. That's the cap off. Yeah, we will have cooked that by subjecting it to this hot air, but we'll just replace it with a new one. And there's the timer off. Just tidy this up then with a bit of braid. Yeah, those pads are loose. That third one along on the bottom is definitely loose. Well, pin 3 actually. Pin 2 looks as if it's damaged as well. Just clean it up here quickly with a cotton bud and some IPA, being incredibly gentle because we don't want to damage anything further. And then we'll compare what's left here to PCB Explorer. Okay, we're looking here at the footprint of where the 555 was removed. Pin 1, which I think is the VCC supply rail for that chip, that all looks okay. Pin 2, you can see the end of it there, the pad, seems to be partly missing, or it's almost like it's been rolled up on itself. But we don't really need to worry about that because the trace from it, as you can see there, is coming backwards. And that all looks fine. We will check all this in a minute though. Pin 3, that's the pad that was moving about as I was desoldering the chip. It does seem to have stuck itself back down there, sort of. You can see a bit of movement in it there. And again, this end of it looks damaged. But the trace also works its way backwards. So hopefully we can just reuse what's there. Hopefully this trace going backwards is not damaged. The fourth pad then, it all looks okay. But one thing that I didn't notice until we're looking at it here now under magnification is that we do have a broken trace here. So there should be a trace from that via making its way down here and across this damaged section coming this way. Ultimately it continues on down the board and makes its way to the mouse port. So it's nothing that would stop the Amiga from working, just your mouse wouldn't work. That's an M1H signal coming up there. So the mouse horizontal movement signal, or one of the horizontal movement signals, ultimately coming through here and making its way over to Paula. So we'll need to patch that, but let's just test those other 4 here while I've got the multimeter out, and it is in continuity. So pin 1, yeah, that's all fine, looks fine anyway. Pin 2, as I say, makes its way back up the board. And it seems to ultimately have gone to where that capacitor was, where that cap was that is now missing. And it looks as if there might have been a trace there as well from that pad going across to that position, ultimately back down to that via. Now if you take a look on PCB Explorer, well, I have highlighted that trace and that's exactly where it does go. So it would have run from here, although there never was a component in that position that wouldn't have been populated. There was a cap here though, but the trace would have came from that via to that position to there and made its way back down to pin 2 of the 555. I can just about pick up a signal there just at the end of that trace that is left there, so we do have continuity to that point. We'll just try and make something to fix this bit. Going back down here then, pin 3 makes its way to that via, and that's okay. So I think if we're careful, we can reuse that. What about the other side of the chip though? Well, pin 5 there, I think, makes its way up to that position. And yeah, that's all good. Pins 6 and 7, you can see that they would have been linked. Obviously 6 is missing, and that would have made its way to that via. Pin 7 is still connected to that, and ultimately would have came to the positive side of the cap that was there. Pin 8 then, that just comes down here, connecting to pin 4. So a little bit to do here in terms of making good. Let's just test that big trace going down there. So it looks a bit rough around that via. So yeah, that does seem to trace out okay. But what we'll do is just go past that via, say down to that one. And yeah, that's alright. Some of the solder here in particular around these two transistors, I think they are. That all looks a bit crusty, doesn't it? So maybe just put a bit of flux on that and reflow all that while we're at it. But let me do a bit of work here to try and repair all of this. I'm just going to be using patch wires for it all, much like you've seen me do before. Just using that solid core Kynar wire. Let me do a bit of that and then we'll be back. So please excuse the glare, but there's an awful lot of flux on this at the minute. I've repaired more or less all the traces that I want to in around the 555. Pad 3 that was in this location, that ultimately just fell off on me. So I've just put a wire there just to replace it. That's made off onto the trace at that position, and ultimately we'll wind up just bending that up, making it off onto the leg when we refit the chip. Things have turned into a bit of a blobby mess of solder here where pad 4 was, or where pad 4 is, I should say. But that'll all sort itself out when we fit the chip. A bit of flux, reflow everything, that'll all be fine. Just here where that trace was broken then, you can see that I have now repaired it with this bit of wire. But just beside it, there's another trace there that was running down underneath that bit of solder mask. And I noticed just a little nick in it, and sure enough, yeah, that trace was broken. So remove the resistor that was here just to get better access to that, and we've put that bit of wire in there just to repair that broken trace as well. Now that also wasn't anything that would stop the Amiga from booting, it's just the left audio channel. At the other side of the 555, I'm not going to do anything where that pad is missing. Rather, when we refit the chip, I'll just bridge those two pins together. They were connected by a trace anyway, ending up at that via, but the next thing I do need to do is put something in place so that we can refit this capacitor here. And that's going to be a bit of this copper slug tape. Yes, I know you can get proper replacement pads for PCBs, but I've used this before somewhat successfully, actually on another Amiga 600. So I see no reason why we can't use it again. Although this time I've got an idea to maybe make it slightly more permanent. So I'm just going to cut a square of this out. Then if we can get it with the tweezers, this might be way too big. What does that look like on there? So yeah, no, that is way too big. I think what I need to try and do here is just cut a bit off the top of this, just so it clears that other pad for the cap, the negative pad. There, that's a bit better. But I'll also need to cut this bottom left corner of it because it's just a little bit too close to that via there. The other corner of it, I'm just going to leave as it is because it's overhanging that other via. I will ultimately need to make a bit of solder off onto that. But yeah, the footprint of this is still way too big, isn't it? But we've done that on purpose. Because what I'm going to do to try and hold this in place is go over with a bit of this stuff. Some solder mask. Now I have to be honest, I've never worked with this stuff before, and doing it for the first time on someone else's board is, well, probably not the best idea. This solder mask was actually donated to the channel quite a while back. It was Gary over on the CRG Discord. He had a couple of tubes of it, he didn't need it, and he sent it my way, so let's see how it goes. Now I did send it with a brush as well to try and apply it with, but we need so little of it here, I'm just going to try and put it on, just with the edge of the tweezers. Just going to try and drip it onto it like this. And we're going to try and paint around the copper, just to leave roughly the footprint of what the pad would have looked like originally. The idea being that when we cure this stuff with the UV light, well, it should go rock hard and should help hold that bit of copper tape in place. So along with the solder mask, Gary sent me this UV torch. I've absolutely no idea how long this stuff takes to dry, and there's nothing on the bottle about it, so I'll just leave it here for a couple of minutes while I go and do a bit of editing. Okay, it's been about an hour and I think it's dry, or well, mostly dry anyway. Might have put it on a bit thick on this right hand side here, but I do think this is going to work. So what I want to try and do here is just put a bit of flux on it. I've turned the temperature on the iron way down and I want to try and tin that up. So yeah, that has formed a nice pad there for us now, onto which we can secure the capacitor. I'm not too sure though if the solder has flowed across onto that via. I don't think it has. I don't think that's made a join there. Where's the multimeter? Oh, it has. Just want to take a look at that under magnification. No, I don't think that has actually joined up properly. I think the reading that we're getting there is maybe even just from that tiny wee point just there. In fact, I managed to get a bit of solder mask onto that via there, which I didn't really want to do. Yeah, look at that. That stuff is actually still wet. Still a bit wet. Try and get all that out of the way. And I think what we'd be better doing is just putting a little bit of wire just across that. But there should still hopefully be enough flux and all down there. Let's try and offer this up. That's all I want there, just something like that. There, that'll do it. I can nip it off just with the knife here. And hopefully that will work. Let's test it with a meter again. So we'll go from there down to that pad. And yeah, that's all good. You can see a little bit of flex in that just as I'm pushing on it. Hopefully, say by tomorrow, once this stuff here has had a time to fully harden, hopefully that will be nice and permanent. Just need to do this one now. And I'm wondering if I should maybe have a go at that pad 3 where that fell off. I wonder should we try and do something with that as well. Gonna put a bit of solder mask over these bits and all, these patch wires as well, just to help protect it. But yeah, let me have a go at that, and then we'll come back to start reassembling once all of this is done. Okay, I think I've prepared everything that I need to. There's that pad that you see me do a second ago, covered in solder mask, and yeah, it looks as rough as a badger's backside, but there is a new pad there that hopefully we can work to. Equally, at that capacitor location, you can see that I fitted that pad there, and that is made off to the little bit of trace that was just beside it here, obviously covered in solder mask as well. What I need to remember to do though, when we fit that capacitor, is the bridge from there either across to that pad or down to that via. We'll just do that with a little bit of wire when the time comes. Down on the 555 itself, well, I didn't bother with that one, just because those two pins are connected together anyway. There was a trace coming up here connecting it to that point, so when we refit this chip, I'm just going to bridge those two traces. They'll do the same thing. As you can maybe see there, I did have a go at it, but I was making a mess. Just because this area was already covered in that solder mask, it just was not working out for me, so decided to give up on that. But down here, we do have a new pad at pin 3, made off onto that wire that we fitted earlier. Yeah, it's all sort of repaired, but it does look a bit rough, doesn't it? I suppose just so long as it works. Hold on a second. Hold on a second. Is that another broken trace? There? I think that's another broken trace. So let me bring up PCB Explorer. And it was this trace. So if we can select it from that via there, that is the left audio signal. So again, nothing that would stop the Amiga from booting, but does need to be fixed. Okay, that trace has now been repaired. A little patch wire there, just with a bit of solder mask over it now. And as you can see, I've just pushed ahead and refitted everything else. So we've got the new 10 microfarad cap there, new 100 nanofarad ceramic. The resistor's back on, and so is the 555. Almost ready to test it, but having a quick look over this whole area, because you know, I missed the break in that one. Although reviewing the footage, I don't quite know how I missed it. It was pretty obvious, wasn't it? But I had a quick look around everything here, just to make sure there was nothing else I've missed. And yeah, there might actually be something. It seems that this component has been reflowed at some point in the past. And the reason I think that is that there's a bit of flux around it, but there's also just a little bit of solder sticking out on the top of that pin there. It's almost as if someone has tried to drag around this, and I think I spotted a cracked solder joint. On the other side of the board then, I've reflowed most of this here just to try and tidy it up a bit, removed that other can which was redundant. I've asked Mitch if he wants those 300 microfarad caps removed or not. You may want to refit the modulator at some point in the future for whatever reason. And if that is the case, it might be better leaving them there. Although if he did want to refit that, he'll have to repair that position there. The pad on the top of that trace comes down here. The pad has been ripped off, obviously when the modulator itself was removed. But going back over to that other side. So this is a CIA. And yeah, if we do indeed have a cracked solder joint on this, there is every likelihood that that will stop the machine from booting. The pin in question is on this side, and there's this fourth one in here, and you can see a bit of crusty flux around the bottom of it. In fact, you can see evidence there of where this has been reflowed in the past, and someone has obviously tried to clean it up with cotton buds or something, because there's little bits of fluff all over the pins of it. But that fourth pin, if I try and tilt this up and zoom in a bit, well, you can just about make out what I think is a crack in the solder joint. Now, it may well be the case that it still reads okay on the meter. Well, no, it's not. Although if I push on it, well, now it's reading okay. Although there's a broken again. So yeah, that must be a dodgy joint in there. I think what we should do is just reflow that entire chip. And yeah, I think that looks a bit better now. Reflowed right around the whole thing. Let me just try and get you a close-up of this side again. And yeah, I think that looks okay now. So the only thing left to do really is test it. Thought we'd do something a little bit different. I have dragged out the old terminal and we've got that hooked up via serial to the 600, and we've got diagram in. Yes, I know that says diagram A500. It's the same thing. But what does it do? Very little. So I've been having a look with the scope, and yeah, I'm pretty sure we still have a reset problem. We take a look around the CPU. I just power things on. Well, on this right hand side here, we can pick up a couple of pins of the address bus and the data bus. There's one of the data bus pins, for example, and we can see that it's floating there at 1.42 volts. One of the address pins sitting there at exactly the same level. So address and data bus on the CPU, they're tri-stated. I don't think the CPU is being reset. Now, reset signal to 68,000, it's an active low signal. So when the system starts up, it should go low, then go high. Now, we are running here, or the power's on, and if I go on to pin 20, which is on the left-hand side of the CPU, which is that one, you can see there that it is high. If I reset though, or power cycle, well, it just comes up high straight away. It doesn't have that low pulse, so there's nothing there resetting the Amiga. Now the reset circuit is all driven by that 555 and that capacitor. In fact, this whole area that we've been working at. And to save us trawling through schematics, we can use this site instead. Amiga guides, and there is a really handy guide in here for the reset circuit of all the Wedge machines. This is it for the A600. Now granted, that does say Rev 2B, ours is a Rev 1.5, but it's more or less the same. So this is the 555 where we've been working. The output of that, pin 3, that is the reset signal. It goes through R515 to an NPN transistor, Q511. That becomes a KB reset signal, which makes its way to Gale. And then it is Gale, or this thing, which asserts reset around the rest of the system, including to the CPU on pin 20. That's what we were measuring. Now the reason that I think it just starts up high for us here is because, well, as you can see, reset is pulled high. It has a couple of pull-up resistors on it there. Because its normal state is high, it's just asserted by Gale when she gets the pulse from this area. Now the reset circuit is a bit circular, you might say, because that reset signal does make its way back to the keyboard MPU, to this NOR gate, through another transistor and back to the 555 again. But the only reason for that is so that you can do a control Amiga soft reset. I don't think that is the cause of our problem here. Rather, I think what we should do is just start testing all this. We will start at the beginning. Let's just start with the output of the 555, which is pin 3. That's that one actually that I had to recreate that pad on. So I'll go on to pin 3 here with the 555, just with the scope. And as per that note there, output will be high for a minimum of 100 milliseconds, and then will be set low. So let's see what happens. Yep, I would say that is exactly what happened. That went high for a second. That's the reset pulse. It's back down low again. So yeah, that bit of it does seem to be working. But the next stop is transistor Q511, which is this component here. Now the pinout of this, looking at it on the board, top right is pin 1, top left 2, and the bottom one is 3. And I think what we should be seeing here on the output of this is that same signal just inverted. So on the output of that, and it's just high. So that's not switching. Could that transistor be the problem? Let's just look at the input of it, just to make sure that our reset signal there is getting through that resistor, R515. It's on the bottom side of the board, so a bit awkward just to test right now. So yeah, there's the same activity there, okay, to the input of it, but we're not getting that activity that we expect on the output. Yep, nothing happening there. I dare say that is bad. So I'm going to pull said component off this spur board I have. Now granted, this spur board, which I recently picked up as non-working, also showing a black screen. So there is every possibility that this is actually bad on here. But I think in terms of this one, what's more likely to be the problem is that capacitor there that has well and truly given up the ghost. It has spilt its guts all over the place, and in fact just removing that, it absolutely stinks. But it should let me get the other one up and running quickly this evening, rather than having to wait for parts to arrive. I will obviously be ordering the parts for this one, and we will be trying to repair this at some point in the future. So let's give it a go. I've got the scope on the output pin of the transistor. And yeah, I think that is now right. When I powered it on there, it stayed low for a split second, then jumped high. Let's just try that again. So on, yeah, turns on, stays low for a split second, jumps high. I think that is now working correct. But the one thing that I noticed, although you won't have because it's just off the shot, when we power it on, when the system comes out of reset, the LED should go bright, and that is not happening. Let's try and confirm that by probing around the CPU again. So we'll just check the reset signal again on the CPU, pin 20, which is that one, I think. And yeah, that looks right. But if we go over here onto one of the data bus pins, and that is just sitting at exactly the same level. That is stuck there at 1.4 volts. What about one of the address bus pins? Yeah, that is just the same as well. So something is still obviously very unhappy, and that is kind of annoying because, yeah, I sort of had myself convinced that fixing that reset was going to solve the problem. Okay, it's a couple of hours later. I've been screwing about with this and not really getting anywhere. I stuck a genuine Commodore ROM in this, version 2.04. Yeah, that's out of a 500 plus, I think, but it'll work fine in the 600. If we power things up though, there still isn't really anything happening. Both the address and data bus still tri-stated. Reset is still working fine, but the one thing that I have noticed is that the HALT signal, well, that has been asserted now. That's why we're not running any code, because the CPU is halted. And if I power cycle, well, you can see that it's never coming out of that. It is just constantly halted from the moment the power is turned on. And that is the same regardless if it's that kickstart ROM in there or diagram. Nothing seems to be happening. Now, the thing that I thought is a bit odd is if I take this out, and if we put in 3.1 kickstart, if I go onto the HALT pin here on the CPU, which is pin 19, and let's power things up, well, you can see it comes out of HALT for a minute and then halts again. And in fact, this time we've got a blue image on the screen. It does vary with Kickstart 3.1. Let me see if I can get it to do anything else. Sometimes we get just the black screen, and sometimes we get this white screen with a black scrolling line on it. That scrolling line can either be going down the screen or up the screen. I have no idea what that's about. Now, up until the point where the CPU does halt, there is activity on the bus. For example, if I go on to one of the address bus pins, and if we power on, there we are, a couple of pulses of activity on one of the address lines, and then it just fails and it's tri-stated again on the data bus. Little pulse of activity there, and again it just fails. And it always seems to fail with the CPU halted. So having a look around the board for clues, and I noticed that the solder points on the RAM, they have definitely had work done to them. And sure enough, talking to Mitch, this board had a RAM fault. Those have been replaced, but I wonder, do we maybe have a problem here? Remember the way that CIA up there had been reflowed, and we seen what we thought was a cracked solder joint? Well, if we take a closer look at the solder joints on these two RAM ICs, some of them look a little bit iffy. The chip is ever so slightly off on the pads, but that itself wouldn't really concern me. Although, the likes of that one there, that doesn't even look as if that is connected properly. And that one at the end, that looks as if that might be cracked. And that's just on that one side of that IC. So I'm thinking what we should maybe do here is just reflow the both of those. And I think to make my life a little bit easier, what I'll maybe do is just remove those two ceramics, just temporarily, while we do reflow it, just so I can get in there with the tip of the iron to make sure we're getting good joints. And let's see if that makes any difference. Could dodgy RAM cause this problem? You certainly need some amount of working RAM in the system for it to boot. you need something even to boot diagram, but I'm not too sure, to be honest, because diagram can supposedly boot to RAM in any address location, and I have tried it with this expansion on there. I know this is good. Just pulled this out of my 600 and it still doesn't do anything. But given what we've seen there under the microscope, I think it would be worth reflowing that anyway. All done. Let's take a look at those now. And yeah, I think that is looking an awful lot better. Will that cure the issue though? I don't know. So unfortunately, reflowing the RAM did very little. In fact, it is just behaving exactly the same. So didn't really think that would solve it, but I think it was definitely worth reflowing that anyway. But since we are only seeing activity with this 3.1 ROM in here, let's try and use that to our advantage. I think what we should do is go around the address bus on the ROM and let's see if there's anything that looks a bit off on the scope. Now it is only running for a couple of seconds, but if we test each one of them individually up until the point where it crashes, let's just see if there's anything that looks odd. So on this side of the chip from pin 2, that is address line A7, and it works its way down to A0. A8 through 15 are on the other side. But let's just check these ones. So A7 first. And yeah, that actually looks pretty normal. And that's it crashed. This time it's threw up a pink screen. A6. And again, for all it did run there, yeah, that looked alright. A5. Yep, that's looking okay. A4. So just a little bit of activity there. Try it again. Yeah, no, that looks okay. A3. That looks fine. A2. That looks fine. A1. Yeah, that looks alright. And A0. Yeah, that all looks fine on that side of the chip. What about the other side? And starting from the second one in again, which is A8. That looks okay. A9. Yeah, again, looks fine. A10. Just a flash of activity there for the briefest second. Let's just try it again. Yeah, no, it looks okay this time. A11. Nothing. Let's try it one more time. Nothing at all. And that's just floating there at 1.4 volts. So yeah, something wrong there. A11. What about 12? Yeah, looks alright. 13. Again, that's okay. 14. Maybe a little bit suspect there, is it? Yeah, it sort of runs for a second, then does that sort of noisy ground level signal, and then runs again, and then obviously crashes. 15. Yeah, that looks okay. Last one. 16. And yeah, again, that looks okay. But the one that most definitely did not look okay was 11. Let's just try it one more time. Yeah, no activity there whatsoever. So could that be a clue? Well, I think we might have solved it here, but don't want to get too excited because, well, I thought the reset signal was going to solve it. But we've definitely found a problem with address line A11, and in fact A10 and A12 as well. The three of those live in this bottom corner of the CPU. And if I bring you in here for a closer look, on the microscope, well, we've got a couple of cracked solder joints. A11 is that one in the middle there. A12 is the one at the end. A10 looks cracked. A9 actually looks cracked as well. And you can see there that it is most definitely gone, because I can move the pin with the tweezers. So how could that have happened? Well, this machine came with one of these things fitted, if you remember. 5.5 meg fast RAM expansion. This clips onto the CPU like that. And this was incredibly tight. Very, very hard to get off. Did take quite a bit of force. That socket there gets quite the grip on top of the chip. But it must just be the force of fitting that and removing it has cracked those solder joints. So we'll reflow right around the CPU just to make sure we pick up anything else that might be cracked as well. And I suppose it is something just to bear in mind if you've got an A600 with an expansion that clips onto the CPU. You may just want to fit it and leave it there once it's working. I wouldn't have thought that could crack those solder joints, but I can't think of anything else that would have done it. It is getting late. It is 11:30 and it is a school night, but I need to know if this is going to fix it. So let me reflow it quickly and then we'll be back. Right, CPU reflowed. Still just going with Kickstar's 3.1. The camera's battery is about to die, but let's just see if we can get any activity out of this now. So power on. That LED brightness changed. So that shows that the system has now properly reset. We didn't see that before. That is a really good sign. Although we are still faced with this black screen. Now I suppose we could take a very quick look with the scope. Kickstar's 3.1 ROM. It's booted. No way. It's working. What? Let me very quickly get diagram in there. Let's just see if diagram boots. Was that all it was? Cracked solder joints on the CPU? Yeah, there it goes. Diagram, straight away. It's working. Fantastic. Well, it's a new day. The 600 still works, but we've had another problem. I have now went ahead and removed the 3 100 microfarad caps that were here, that were associated with the RF can. Spoke to Mitch about it, he wanted them off, so they're off. Now, I did unfortunately lose a pod when doing that. Just that one down in there. That, boys and girls, is why we don't use these things to remove caps. I was being lazy, I did just cut them off. I suppose they're redundant anyway, since the RF can is gone and will never be used again. I didn't want to use hot air because doing so would have damaged these caps, and I don't really have any other means of removing them. I have no hot tweezers. But that's done, and I have replaced those 2 capacitors there as well. But speaking with Mitch, he asked me just to give the whole board the once over, and as you can see, we're now hooked up with Composite video. I thought we would just test this, since there obviously has been a lot of work done in this area, and that Composite encoder has been replaced in the past. But as you can see there, that Composite video signal is terrible. So I've been having a look around trying to figure out what's going on. And one thing that I noticed that might be a little odd, that encoder gets hot, like really hot. Not hot enough to burn you by any means, but uncomfortably hot to touch. But I'm not sure that is the cause of the problem. Rather, if we turn this thing over, well, there's a series of components here, resistors and capacitors, and they are dealing with PAL video stuff. If I touch that capacitor at the end, that really upsets things. The image goes black and white, or sometimes the colours on it get screwed up altogether, something like that. So the colour clock signal works its way through all of this. This 7474, that's also involved in it, and ultimately it makes its way to pin 6 on the encoder. I have tried reflowing right around the encoder there, so I don't think there's any issues with that. But I think what we'll do is reflow around this 7474 and just all these components here on the bottom side as well, just to see if that makes any difference. So is that any better now? Power on. Yes. That's what it's meant to look like. Not a bad signal actually for Composite. I don't know if he's going to be using it with Composite or with RGB, but at least now he's got either option working. So that's it all back together. We've got his own 3.1 kickstart in there, 5.5 meg fast RAM, the 4 gig CF floppy drive, everything is hooked up again, including the keyboard. It has booted to its CF card there, just seems to be a very basic installation of 3.1. Let's stick in this disk, which is Amiga test kit, because I want to run that just to give everything a quick test. Now we can launch it from within Workbench, but just going to boot to it directly. We'll just do a reset. Maybe. Or maybe not. I wonder, do we have another problem there? Because that should be working. We'll just hard reset it for now. And yeah, it's booted into Amiga test kit. Okay, mouse working. Yeah, that seems to be fine. But let's test that keyboard in F2. So it doesn't seem like the enter key works, or return. Well, it does when I push quite hard on it there. I wonder, does the keyboard maybe just need a clean? And that right Amiga key didn't work either. Although it does if I push on it quite hard. Can we reset from here? Maybe not. Can we reset from here? No. That seems weird. HALT does a system reset within Amiga test kit. Yeah, okay, that worked. But I do think the keyboard itself needs a clean, so I'll strip it down and we'll just give the membrane a quick wipe over with a cloth. While we're in here though, let's just test everything else. So 6.5 meg of total RAM. Oh, I said that was 5.5 meg of fast RAM, it's not. We've got the 1 meg of chip, 4 meg of fast and 1.5 meg of slow. But we will just run a complete memory test, and I'm going to leave this going around for a while here just to make sure that it's all okay. Because one thing that Mitch did say to me was that it had some problems getting the RAM on this expansion here to be detected. That might though have been down to those cracked solder joints that we found. He did tell me that he's had this on and off quite a few times trying to figure out what was going on. And given how tight it is there, well, I think that probably is the cause of the cracked joints. And I suppose it's just got worse over time, ultimately leading to the failure that we seen. Okay, it's on its 10th iteration there. It's fine, no RAM issues. Let's try the controller ports. So joystick in there, it's all working. That's working. Mouse. Yeah, that's all fine. Just going to swap these over quickly so that I can test the second button on the joystick. Just using the mouse. And yeah, that's okay. Audio. Yep, that sounds good. Low pass filter. I think that's working. Yeah, that's fine. Video. Oh, it looks okay. Yep. CIAs. That's all good. And our serial and parallel ports. I do have the two look back dongles in there. So serial port first. That's all good. Parallel. Yeah, that's all good. I think the only thing that I really need to do is take the keyboard apart, because there definitely are a couple of sticky keys in there. I'll take it apart and just give the membrane a clean. So yeah, it is one of the new hard membranes, but we'll just give it a quick wipe because it isn't that old, and it's maybe not an issue with the membrane itself. It's maybe more an issue with the wee plungers. Maybe they need a clean. It did take something off it though, because this cloth was spotless and you can see dirt on it there. To clean these plungers, I'm just going to use a dry cotton bud. We're just going to give it a wipe, just like that. That's enough just to remove any debris or anything that may be on them. Don't want to use IPA on them because they are carbon pads. I don't want to rub the carbon off. So no liquid, just a dry cotton bud, and I find that's usually enough. Let's test it again. So return, yeah, working straight away now. Fantastic. The other sticky one was the right arrow key, and yeah, that's fine. What about that Amiga key? That was a bit sticky. Well, it does work, but it still just needs a bit of a push. Or, well, no, there's a common good now, actually. Yeah, no, that's okay. What about the reset? Amiga control. Nope. No, that is not working. So I've been screwing about with it, but no, the keyboard reset just does not work. It's not a problem with the keyboard though. It's not a problem with the keyboard MPU. Must still be something wrong in the reset circuit. And I can show you that. Because this component here, this 7427, this is what controls the keyboard reset. We did take a quick look at this earlier, and I did reflow around this IC earlier. But I can show you on this that it's working in relation to the keyboard. So if I go on to pin 1 of it there, you can see that that is a high signal. But if I push control, you can see that goes low. Pin 2 of it, also high. But if I push this Amiga key, it goes low. Then pin 13 of it, also high. But if I push the other Amiga key, that goes low as well. The output of the 7427, which is a triple input NOR gate. So with the 3 high signals going into it, the output on pin 12 is low. But when those 3 high signals all go low, when you push Amiga, and control, if I can reach it, there, you can see that the output goes high. That should trigger the reset. Now if we go back and look at the schematic for it, well, it goes through another transistor, Q622, and considering that the other one above it, controlling the reset, considering it was bad, now I'm wondering, is that one bad? That output of it there is high. When I trigger a reset here, that should go low. And it's not. So yeah, that must be the problem. Okay, I've swapped out that transistor. So let's just go on to the output of it here with the scope again. And let's try a soft reset. Yeah, pulled that low. System did reset. It's now working. So I think that's everything for this 600. I think I'll just put it together now before anything else breaks. Well, that was quite the challenge, wasn't it? But it's all up and running now. Everything's working. It's all been tested. Outside of Amiga test kit, I did have a game of Lemmings on it, and it's all working fine. So I'll get it boxed up and on its way back to Mitch. Hopefully it continues to work well for him. I am always a little bit nervous of the type of repairs that we did in here, especially around that reset. just with those small patch wires, and in particular those new pads that we created. How long will that really last? I suppose in theory it should last forever, but it will always be a weak spot, won't it? So if you do have any problems with it in the future, well, you know where I am. But I think that'll do us for now, because this video is definitely long enough. So if you enjoyed what you've seen, I would appreciate a thumbs up. Why not hit subscribe if you haven't done so already? Still a few things yet to do here on CRG, and I'll see you next time.